Okay, so we have learned what the Pythagorean theorem is, and we have learned how to use it to find sides in a right triangle if we know two other sides. Today, we're going to use the Pythagorean theorem. I'm going to abbreviate it in real-world applications. Okay? All right, so this is going to involve drawing because we're going to be talking about right triangles, and anytime anything on a problem starts talking about a shape and it's not drawn for you, you need to draw it, okay? That will help tremendously. Here we see that the bottom of a 10-foot ladder is 2.5 feet from the side of the wall. And part A says illustrate this situation with a right triangle, labeling the ladder, the wall, and the distance from the wall. Okay, so we need a right triangle. Something's going to be the hypotenuse, two other things are going to be the legs. So we've got a wall. Now, just to be silly and because I don't really know how to draw, here is a house. Okay, so over here is the wall, right? And we have a ladder leaning against the wall. So here's the ladder, and here is the ground, right? Ladder and ground. And while this is not a great illustration, what we need to see is that the wall, the ladder, and the ground make a right triangle, right? Now, it says that the ladder is 10 feet. So where does that 10 feet go? Well, that 10 feet goes where the ladder is, and the ladder is what's leaning up against the wall. So the ladder is 10, and it says the bottom of the ladder, well, where's the bottom of the ladder? It's right here, and it says the bottom of the ladder is 2.5 feet from the side of the wall. So this little part on the ground here is the 2.5 feet. My stylus is not wanting to cooperate. Okay? Now, do you see that the ladder would be C, right? Which means the ground and the wall would be A and B. Okay? That's important. We've got to get C right. If we get C in the wrong spot, we'll miss the problem. Now, it says how far to the nearest tenth is the top of the ladder from the ground. So we're trying to find this distance right here. So we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. A, as I have set it up, is 2.5. We're trying to find B, and C is the ladder. Okay? I want you to pause the video, finish solving this problem, write your sentence, then turn the video back on to check it. I got, when I solved, that B was approximately 9.7 when I rounded to the nearest tenth, since that's what it told me to do. Remember, make sure you follow instructions about rounding, and I say that the top of the ladder is about 9.7 feet from the ground. If you miss something, correct it, and then let's go to the next problem. Okay, this next problem has to do with direction. It says two hikers start a trip from the camp walking 1.5 kilometers due east. They then turn due north and walk 1.7 kilometers to a waterfall. Part A is draw a triangle, just like we need to do. It's a right triangle. We need to draw it. We need to label it. So we start here. We start at their camp. Okay, that's their camp. And it says they start out by walking 1.5 kilometers due east. So I drew a line segment in the direction of east. Then they go due north. If that way was east, then this way is north. And they went 1.7 kilometers, and they ended up at a waterfall. Now, what we're trying to decide, it says to the nearest tenth of a kilometer, how far is the waterfall from the camp? This would be, as my dad would say, as the crow flies. What's the shortest distance from the camp to the waterfall? It's that right there, okay? I want you to decide what A, B, and C are. I want you to do the Pythagorean theorem, solve, write your sentence, turn the video back on, and check it. The distance from the waterfall to the camp is the hypotenuse of the right triangle. Here's the little right angle box that I didn't draw in. So we're solving for C. I got that C was about 2.3, so the waterfall is about 2.3 kilometers from the camp. Briefly, we want to look at the converse of the Pythagorean theorem. The Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. Okay, that's what the Pythagorean theorem says. The converse of the Pythagorean theorem swaps that around. The converse says that if a squared plus b squared equals c squared, the triangle is a right triangle. Now, not every converse of every statement is true, but in this case, in the case of the Pythagorean theorem, which I'm having trouble saying right now, it is true. If you have three lengths and a squared plus b squared equals c squared, then you can be assured that they make up a right triangle. Okay? Now, this question here says, is a triangle with sides 7, 25, and 24 a right triangle? The important thing is which one would have to be C. If the sides were 7, 25, and 24, which one would have to be the hypotenuse? The longest one would, right? That would be C. So we're trying to figure out, is 7 squared plus 24 squared, does that equal 25 squared? That's what we want to know, okay? So we're going to do a little bit of calculation here. And guess what? We get that 7 squared plus 24 squared does equal 25 squared. Okay, so we would say, yes, this is a right triangle. Our answer would be yes, that it is a right triangle. Okay? All right, so the next thing they give us the sides 6, 8, and 12. I want you to decide which one would be C. Set it up using the Pythagorean theorem. See if this would be a right triangle or not. Then check it with my work. Did you get no? All right, sorry about that. That was my phone. The hypotenuse would be 12 because that's the longest side. When you plug that into the Pythagorean theorem, you get 6 squared plus 8 squared is 100, and 100 does not equal 12 squared, which is 144. So this would not be a right triangle. All right? Mark anything you have a question about. We'll do some practice with the word problems in class.